Okay, so let's say we have, for example, a complex number of 1 plus root 3i. And that's our standard form, a plus bi, but sometimes we write it in this weird complex form, where instead of talking about this being the real and this being the imaginary, and you going 1 on the real and root 3 on the imaginary, we talk about it in terms of the angle that it makes with the axis and the radius, the length from the origin. So in this case, if that's 1 and this is root 3, then the angle there, I've rigged it so that it's a 30, 60, 90 triangle, so that your angle is 60 degrees, and then that radius with Pythagorean theorem is going to be 2. So you could call this thing, the radius is 2, the cosine of 60 degrees, plus I sine 60 degrees. And if you were to work this out, and cosine of 60 degrees, I'm going back and forth here, but the cosine of 60 degrees is a half, and the sine of 60 degrees is root 3 over 2, multiply that out, you do get back to there. So this is a complex form, this is your standard form. Now why the heck would we ever want to write it in this clunky looking form here? That's what they're asking us. So looking at our possibilities, why would we want to change this pretty looking form to that ugly looking form? Not for graphing. I graphed it just fine as going 1 over on the real, root 3 up on the imaginary. I have no problem graphing in standard form. It's not hard to graph in complex form. You just go 60 degrees up and 2 out. But I don't need to convert to complex form to graph. For part B, finding the complex conjugate, I can do that in standard form, no problem. The complex conjugate of 1 plus root 3i is 1 minus 3i. No need to convert to that wacky form for that. Finding the absolute value, don't need to convert to do that either. If I want to find the absolute value of 1 plus root 3i, remember absolute value when you first learned it was defined as the distance from 0, or the distance from the origin? Well, that's what it is here, and that distance just by Pythagorean theorem is 1 plus root 1 squared plus root 3 squared is root 4, which is 2, which is confirming what I got from my 30, 60, 90 triangles there. So no need yet to convert to that wacky form. What the heck is this wacky form used for? Ooh, perhaps raising to a power. What if I wanted to take 1 plus root 3i, and I wanted to take it to like the 6th power? In order to do that in this form, I would have to do 1 plus root 3i times 1 plus root 3i times 1 plus root 3i, etc. And FOIL, 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 FOIL. Oh god, pain in the butt, right? Don't want to do that. So this form has a shortcut. This form says that if you're going to take some complex number to the nth power, that's going to be your radius to the nth power times the cosine of n times the original angle plus I times sine of n times the original angle. Interesting. So this is our answer. Our answer is D. Let's just play with this a second to make sure this thing actually works. Let me get some room here. So, let's say that we wanted to find out what, we'll do one that we can check, right? If we wanted to find out what z squared was, and this is our original z, then I could do it by taking 1 plus root 3i squared. And this one is not hard. I chose one that we can do. This is 1 plus 2 root 3i plus I squared, plus 3i squared. When I multiply that out, when I FOIL that, right? 1 plus root 3i times another 1 plus root 3i, it gets FOILed, I get this. When I simplify that, I get that. So I get minus 2 plus 2 root 3. Now, let's check that we get the same thing using that wacky formula I told you about. So this says that z to the 2nd power, remember my formula was z to the nth power should be r times the cosine of n theta plus I times the sine of n theta. So my r in this case, the radius was 2, and n in this case, because I'm raising it to the second power, is 2, and my angle was 60 degrees. So I sine 2 times 60 degrees, and 2 times 60 degrees is of course 120. And so you could say that this is 2 cosine 120 plus I sine 120. That's not hard to do. And we can check this. We can, like, that's a beautiful complex form. And if they wanted their answer in complex form, you'd be done. If we want to check this by putting it back into standard form, just figure out what these are, because I've rigged these, we happen to know them. So the cosine 120 degrees is going to be negative a half, and I times the sine of 120 degrees, sine of 120 degrees is root 3 over 2. Now I just noticed that it was supposed to be, this r is supposed to be r to the n, so it should be 2 squared. So these here should be 4s. Sorry about that. Because now when we distribute the 4s, we get negative 2, 4 will cancel out, 2I root 3. Oh yeah, it matches. Yeah. So this way would have been a lot easier had I gone to a bigger power, because then I would have had to do a lot more foiling. But this way here would have been so very